sweet alert for everybody. So I'm gonna keep and explain a lot of we're gonna do a lot of examples, and at the same time we will be working on Docker desktop as well as Linux both at a time, so that you will get a clear idea of what does that command mean. I will explain the usage of command, and I will use the command in Linux machine using Docker engine, and I will show that a similar command working in Docker desktop, so that you can have a parallel running. We will do the parallel run so that you can have a clarity until until you get the more exposure on that. Once you get the enough exposure, enough understanding, then we will use only Linux. Okay, so now let's sneak peek into Docker. Now you know a bit about how Docker can help you. Before we dive into a real life examples, a real case examples, let's go over a couple of core concepts. So, so in this slide, we're gonna cover some key Docker concepts which are illustrated in the in in the in the infographic that you will be seeing. So the first one, on left part you see the Docker host machine, and on right part a portion you can see running processes. Okay, so it's most useful to get the concepts of images, containers, and layers clear in your mind before you start running Docker commands. In short, containers are running systems defined by images. So these images are made up of one or more layers or set of diffs plus some metadata for Docker. You see that example, we have taken one. This is our Docker host machine. Inside that Docker host machine, we have an image. So this is our image. It's a complete image. Image is nothing but, what is image? A simple definition. An image is made up of one or more layers plus some metadata for Docker. That's it. So layer 1, layer 2, layer 3. So layer 1 is basically a base image. We have taken Ubuntu distribution, a miniature Ubuntu distribution. Then after that, application code layer, because we want to deploy some source code, some application, so that application is in second layer. And then the third layer is application version 2. We have attached a few more features and that. So total, this is our image is consists of a layers. That's it. Now what is a container? Containers are running systems defined by images. So whatever instructions that you defined inside an image, all those will be running. Those all those commands and all those services are run will be run. So will be run. If they are run, that's called a container. So the containers are running the systems, services, commands that are defined by images. That's it. These are the simple definitions of a container and an image. An image is a collection of file systems, layers, and some metadata taken together, so they can be spun up as a Docker container. So Docker container is nothing but running the services, systems, commands that are defined inside the Docker image, inside the image. That's it. So let's look at so if you take this example here, another layer we have added. That's a layer is a collection of what is a layer? A layer is a collection of changes to files. So you can see that the differences between v1, that's version 1, and version 2 of application code layer are also stored in this layer. So now once you run this container, when you say docker run, let me give that. Once you say a docker run, so the systems and the services which are mentioned inside the docker image will be running. So then we call them as a running processes, because the process, ultimately the processes which are defined by the image will be run. So then your, that's what our containers. So then once it is running, we call that as a container. So but inherently what is running, the processes that we have mentioned inside the image are running inside a docker container. Okay, so that's our version 1. If you run it again, slighter modification, we will get a container version 2, and if you run it again, we'll get container version 3. So like that, you can run any number of containers with the same image with the slight modifications. So these are all version 1 of 3 containers, and after that you have done some changes, you have added new services into your docker image, and then you have run it, then you got the my application container version 2 1. So these are all. So one side you see the image and their layers and instructions which are mentioned inside the layer. On other side, when you say docker run and image name, so it's gonna run the services which are mentioned inside the image, and inside the image. So that's what you are seeing on right side, running processes. So let's see. So a container is a running instance of an image, so you can have multiple containers running from the same image. So the principal docker subcommands you will use on your host are docker build. This is to build a docker image. Docker run, to run a docker image as a container, or the better way is to say to run the services or processes or commands which are defined by the image. That's what the correct way of putting docker run. Then docker commit a docker container as an image, and finally docker tag, to tag a docker image, to give a name to the docker image. So now let's do our first practical real case example. So that is run nginx container. This is example 1, nginx container in ubuntu based server using docker engine for inspecting. Okay, let's get into that. So we will do our first exercise using Jenkins. Sorry, nginx. Okay. So what will we do is, let us get into the Docker engine which is installed in Docker server, which is Ubuntu based. So here it is. I think it's gone. Yeah. Clear the screen. Now let me check Docker PS. So sudo I docker ps. So no container is running presently. So let me say docker images. So only one image is presented, that is hello world, that we have used in our last example. Okay, clear the screen. So now what will we do is, we are gonna pull the image from Docker Hub repository. So now let me show you the Docker Hub repository first before we pulling the images. So this is Docker Hub. So this is my account. So these are the images which I have created. So but if you click on explore, you can find the images, official Docker Hub images. So here, okay. So now which image we want to go? So it's pretty easy. It's similar to any other social media account. So you can click on Docker Hub login and give your name, username and password, and that's it. You can log into the system. Or if you have a GitHub account, you can use your GitHub account to log into your Docker Hub. That is also fine. So now nginx is the one I want to use. So let me click on nginx image, nginx Docker official image. Click on nginx. Now you can see that Docker nginx, you have two options, overview and tags. So if you come here, you will get the complete information of the about the overview. As these are official images, you can get documentation of that also. What is nginx and how to run that example also you will find. This is how to attach a volumes to that volume, that's bind mounts, and this is to write your custom made basically to custom made your own Docker file, and here exposing it to the external world. Okay, let's get back to this, but before that, what we are going to do is, let's scroll up and go to tags, and here you can find out various versions of the nginx image. So which one I would go with, this is latest tag, I would go with the stable one. For that, I would click on here. So it will copy the Docker pull nginx table and nginx table. So copied that command. So now let me get into my, so Docker help. Uh, where is that? Just a minute, I'll show. Docker pull, yeah. Docker pull means it pulls an image or a repository from a registry. Okay, it pulls an image or a repository from a registry. So now let me paste it and let us pull nginx. Okay, let's pull nginx stable, that's tag nginx stable image, Docker image from Docker Hub, and click enter. So now the nginx with stable tag has been being pulled. So you can see the layers, different layers. It consists of layer 1, layer 2, layer 3, layer 4, layer 5. Each layer has been identified with the specific ID. What is that we are going to see? And finally, let me do Docker images. Clear the screen. Docker images. Now you see nginx stable tag, and it's 142 MB. It's huge. Okay, so now we have our image. Let me check. There are no containers. Now it's time to build our container. It's time to run our container. Okay, so before we spin or run our container, I just want to inspect the nginx image. Let us inspect what is there inside the nginx image. So for that, how to inspect? Just say docker, then inspect and image name. So it is nginx, it's nginx stable. So let me take this so that we can have more clarity. So now here what we'll be doing is, this is so first pulling an image, then inspecting the image, then running the survey, running the processes or systems defined by the image. Okay, So that's why before we run the processes which are defined by the image, let's inspect the image first. Pulling an image is done. So now let's inspect the image. This I will name it as example 1. So inspecting the image. So now you could see that clearly. When we click on inspect the image, it opens up a lot of information. The image has been completely exposed. Each and everything of that image, most of the things of the image has been exposed to us. So let us go into that one by one. So it has begun with the ID. Here you can see the ID of the Docker image, and then a report tags. You see that tag, it's stable tag, and a report digests. Then scroll down, the most important, and when it is created, that's okay. And container config, exposed ports. So this is important. This is container port 80 TCP. Then environment variables which are related to this is path. This is the path. nginx version is this, and when you say nginx version, you'll get it. This 1.22.21. Okay, let me copy this environment variables in, and when you use exec, that time we can use it. So in the second step here, you have to copy that. Okay, yeah. So then environment variables of nginx, then commands. So this is what is the command will be executed mainly when you say docker run nginx and G, option G, daemon off, and image volume null. So working directory is nothing is mentioned, and entry point is this docker entry point dot sh. Labels, they have maintainer, they have mentioned the maintainer, that is nginx docker maintainers. Then docker version, it's given other. So there are a lot of other stuff. Okay, and again environment variable. Okay, and virtual size, overlay, and type layers. See, these are the different layers. You see how many layers it has. 3 plus 3, 6 layers, and finally you got the metadata. This is our last step. So this is how we inspect the docker image. Okay, so inspection is done. So now let's get into inspection is done. So now let's get into running the processors, running the systems defined by the image. Okay, for that let me show you the method. So let me take to the overview, and here what is nginx, and first option hosting some simple static content. Okay, this is the way. So docker run is our command, name of the container that you want to mention, and then here image. So name is the option, and after that you have to give the image container name that you want, and then this is mountings, this is bind mounts. So anyway, now we are not using this, and after that it is detached mode, and finally the name of the image. This is one way of giving, and the another way, so place this file, or you can give docker run name and detached mode and image. Okay, and this is one way. If you want to expose this to external port, and this is what we have to use. Anyway, we want to expose this to external port so that we can access this application. So then we have to use docker run name option, that's a long option, then name of the container, then detached mode. D option is detached mode, and P option is the port mapping, then image name. So let me copy this. This is without any port binding. It's just, and get into our machine. So I'd say and paste it. Okay, so let's say docker and run name. I'll give nginx or load balancer and detached mode. Run this in detached mode. I don't want to print on the screen. I don't want to print the output or logs of this container on the screen, so that's why I said detached mode. Whereas a hello world example, we have run interactive mode. In that, the message has been printed on the screen. Okay, so then I'll go for the port mapping 8080 with 80 of the container, 80 of this server, this EC2 instance, or this Docker server. The name of this EC2 instance is Docker server. So 80 of the Docker server with the 80 of this container that we are going to run. Then nginx image name and stable. So let me run it. It's done. It's been built very quick, very fast, because it takes a lot of time to build an image, but to run a container it takes seconds. Why? Because the image consists of everything. As we have seen in our previous slide, you see, this is our image consists of all the information, everything. It consists of everything. So that's why it is too heavy to build an image. It's heavy. Whereas a container, what container does nothing other than running some commands or running some systems or running some processes. That's it. So image will do a lot of activities. It's like carrying an OS or carrying some information. So let me get into that, and I'll say docker ps. Now you see nginx stable, and name of the container is a load balancer, and docker, and it is running at this IP at this port, and that been mapped with this. So 58 seconds ago it's been created. Now status is up and it's running. So now let me go to the AWS and let me take the public IP of this. So click on Docker server public IP, copy this, and click on new tab and paste it, and 8080 and enter. That's it. Congratulations, you have run your load balancer or nginx service using a Docker container. This is your first Docker container service that has been run from Ubuntu service, and you have used the public IP and with the port, and you are able to access it from remotely through internet. It's not a local host. It did not happen in your local host machine. You have accessed it through internet with public IP and with port. Congratulations, a big congratulations. You are moving ahead. Okay, so now, but this is not our agenda. So our agenda is to cross check. Our agenda is to check these things, whether if you open that, will you find this information, will you get this bin boot tmp where root home, will you find this application code layer, will you see that? Let's look into that. That's what the main agenda. So the main agenda in this exercise is to, so running is also successful. So now the main agenda is to look into the layers of the image by using the container terminal. Okay, that's what the main agenda. Let's get into our terminal, get into our Docker server again. So everything is fine, but let's check the Docker logs and then let's look into the other one. So Docker logs and container name is a load balancer. You see that this Docker log, yes, we have said detached mode, we gave D option, so that's the reason these Docker logs has not been printed on the screen, or else it would have been printed on the screen. And Docker log, what is happening at every second is all been printed on this. Okay, which is executing at what time, you see, using the epoll event method, start worker processes, and then now 157.42.47, this is a IP, and when I call this, it's the get method as comes into the picture, the get method, and then it has fetched this, and using we were able to look into that using a browser. So that's what is happening here. So now let us enter into the terminal of the container. Okay, so now you just observe this. Okay, let me clear the screen first. Before that, docker ps, let me give, okay, let me keep this. Then docker first observe this. Now at this moment, root, who am I? A root user. These are ubuntu user, other processes which are running. Okay, so root is the user and this is the host name at this moment. Okay, just remember this, or I would copy this there also. This is our total prompt, out of which this at this moment, these are the root. Okay, root user, root is user, and I this one is our host name. So now let me say docker exec and option I interactive mode t terminal. Terminal, it will take bin bash. So container name load balancer, and which terminal I want to use, tty bin bash. So now let me copy this again and I'll paste it here, copy and paste it here. So what's the difference between this and this? User, root user, this is the host name, IP 172.31.41.36, that is private IP of our EC2 instance. Here username is root, whereas host name has been changed. Host name, what is this? This is the container ID. Okay, you see that 74E9B494496E is the container ID. Okay, so now where are we? Where are we? See, host name is this container ID and this. So that means we are inside the container now. Now we are inside the container. So now let me clear the screen. As we are inside the container, Okay, now we are inside the container. So now what I'm gonna do is, so I will give ls first to find out. See, this symbol means where are we now? We are root home directory. ls, we are in root home directory. So I will go into the root virtual directory. Yes, so this is the root virtual directory. You see that? You see exactly the directories that we have mentioned here in our slide: bin, boot, tmp, var, root, home. Here also you will see same thing. You see, bin, boot, dev, etc, home, media, proc, as bin, tmp, lib, mnt, root, srv, user, opt, run, sys, var, everything, almost the copy of an os, a copy of an ubuntu. Okay, why? Because it's a ubuntu os. It is ubuntu distribution, but it is miniature. You might not find all the you might not find all the utilities that are there in our EC2 instance machine. May not be. You might not find all of them. Okay, you can find very few because this is a miniature level and it is lightweight container. So that's the reason. But the point I want to prove here is Docker image is nothing but a layers. That is first. And second, the Docker container is nothing but it consists of a miniature distribution. Inside it could be Ubuntu or anything, and inside, as a normal virtual machine, a normal EC2 instance consists of these directories. Similarly, a container will also consist of same directory. How the EC2 instance works or virtual machine works, similar way the container directories and their functionality, everything works in the same way. There is not much of difference. So let's explore more inside the container. So I will give ps. So you see that ps command itself is not there. That's what I am saying. ps is to fetch the processes which are running now, but ps command itself is not there. So apt update, I will up. I'm doing these operations inside the container terminal. Okay. So now I'll install apt install ps. I'm installing the ps. Unable to locate package ps. That's okay. Whatever it may be. So ls run sys var. Now let us get into var directory, var ls backups liblock run and cd to srv ls. Nothing is there inside the srv. And cd user. Inside that you will find bin lib. It's exactly similar to our EC2 instance or a virtual machine, Ubuntu machine, because it consists of similar things. Nothing. There is not much of difference between this and that. So hence, this has been proved. The layers inside it will consist of the similar directories, and we can log into that using this. So this is proved. So now I have to exit from here to come out of that. So now exited. Now you see, now the host name is IP 172.31.41.36. So this is the host name of the EC2 instance Docker server. This is the host name of the Docker container. So now, so this has been proved. Okay. Main agenda, this has been proved. And let me enter into the one more time, Docker exec it and load balancer, and it is bin bash. Now echo nginx. Yes, that's it. You see that nginx is there and it has printed nginx version. So that's 1.2.2, and more we'll check. Nginx version is done. So path, we'll just say echo path. See that these are the paths normally: user local has bin, or user local bin, or user has bin, or user has bin, or has bin. So these are the different paths. All each path is separated by colon. These are all colon separated. And one more, we have package release. We'll go package release also, will get one bullseye. Okay, now let's get out of from the container. So now this part has been proved. So now we are going to run more containers from the same image with different versions. Okay, so the initial container is just a load balancer. Then after that we'll create load balancer version 1, load balancer version 2, load balancer version 3, and we'll see what's going to happen. So now we'll run more containers from the same nginx image and see what's going to happen. So get back to our and clear the screen, and it is docker run the command docker run. Immediately after that we will give name option, and the name is load balancer and version 1. And after that we will put it in detached mode. Then we will give port mapping. So 80, in spite of 80 I will give 80, but this time 40, 8040. No, I will give 8010 for this, and for other one I will give other one. So 8010 port mapping with 80. Then name of the image remains same, nginx latest stable. Sorry. So let's build. Okay, invalid container name. Okay, that's fine. I gave it in a wrong way. Done. That colon should not be used. That's my mistake. Sorry. So now I will check ps. Okay, sorry, docker ps. You see that you have two images. One is load balancer. Sorry, two containers. One is load balancer. Other one is load balancer version 1. So just now it's been created, and 8010 is where it's running. So let me copy the same URL and paste it here, but 8010, correct? 8010 here. One is 8010, other one is 8080. So let me get that. So let me execute it. That's it. That's it. It's not magic. That's how it works. So and here, so now two containers are running inside my server. One is 8080. I have refreshed it. You see that? Refreshed it. Still it's working. If you have a doubt, I will copy it and close it and paste it in a new browser and see. See? It's working. It's hosted. It is live. It is not a local host. It is running through internet. and here again 8010. So two containers are hosted, two are running now, two are running. Okay, you see that? Two containers. You see this? Container 1, container 2 from the same application, and they are hosted in different ports, and both are running and both are visible. So that's the power of containerization. That's the power of containerization. So let me get here. So we will run one more container. Same. Everything remains same. Port mapping would be 8020 this time. And this is version 2. And here rest all same. Okay, let me execute. Docker container has been spun. You see that? Docker container has been spun. Let me check the docker ps. Now you see, let me make it a little smaller. Yeah, this is fine. So three containers, version 2, load balancer version 2, load balancer version 1, load balancer. So three containers are spinning now. Okay. So now this is spinning at 8020 port. So now let me click it. Let me check that also. Copy this and take a new tab, paste it. But this is 8020 port, and execute and see the magic. Ting, 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 ting. That's working. So one server, one instance, three containers. One instance, three containers still running. All are running. Let me refresh each and everything. Refresh, running, refresh, running, refresh, running. Okay. You see that? Single image, three containers. Container 1, container 2, container 3. So let me run a final one. And this time 8040. It is version 3 and execute. Rest all remains same. It's also created so fast. Now give docker ps. Now you see 4 containers now. Load balancer version 3, load balancer version 2, load balancer version 1, load balancer. So load balancer version 3 is at 8040 port. So let me copy this and go to the browser and okay, copy this and paste it in new tab and change into 40 and execute. You see your page. That's it. So one server, 4 containers at 4 ports, still up and running. No problem at all. Hence proved. With one image, you can principally run any number of containers with the same image. That's the power of Docker. Hence, we have successfully proven two things. One is the Docker image consists of a miniature level of OS inside that. Second one is it runs processes with a single image. You can run any number of containers. So it's done. So the exercise, Ubuntu based server using nginx container in Ubuntu based server is successful now.